Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about question bank on Module 1. So our Module 1 is Random Variables. So contents is here, the question bank of random variables. Part A, short answer questions. Part B, long answer questions. Part C, problem solving and critical thinking questions. Okay, so in random variables, we have discrete random variable and continuous random variable. Discrete random variable and the second one is continuous random variable. And the next topic is here probability distribution. So in probability distribution, discrete probability distribution is there and continuous probability distribution is there. So discrete probability distribution is nothing but PMF and continuous probability distribution is nothing but PDF. Okay, and also this is second topic and the next topic is mathematical expectation. So these are our topics in random variables. Now we'll discuss about question bank of part A first. So part A, first question, state the classical definition of probability. So the classical definition of probability is probability of an event equal to, so favorable events divided by total number of events. The favorable events are denoted with M and the total number of events are denoted with N. So that's why probability of an event equal to favorable events divided by total number of events, that is equal to M by N. So coming to the next question, if expectation of x equal to E and expectation of x square equal to 100, then find the variance. So we know that the formula is variance of x equal to E of x square minus expectation of x whole square. So E of x square means here 100 minus E of x whole square is 6 square. So that is our second question. So coming to the third question, if 3 coins are thrown at a time and x denotes the random variable which is defined as x of x equal to number of heads, write the probability distribution. Write its probability distribution. So here we are going to find the probability distribution for tossing 3 coins. If we toss 3 coins means we will get the sample space consists of, for tossing 3 coins means the sample space consists of head, 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 tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, head, tail, 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 tail. So total 1, 2, 3, 4, 5, 6, 7, 8. So total 8 possibilities. So now we are focusing on number of heads. So now we are focusing on number of heads. No? So here we have 3 heads. Here we have 2 heads, 2 heads, 2 heads. So this is 1 head, this is 1 head, this is 1 head and this is 0 head. So therefore the random variable consists of 1, 2, 3. Okay. So then we need to find the probabilities for those random variables. For probability of x equal to 0 is we have only 1 possibility out of 8 possibilities. According to our probability definition, probability of an event equal to M by N. Favorable events divided by total number of events. So like that P of x equal to 1, that is equal to, so for x equal to 1 we have 3 favorable events are there out of 8 events. So like that P of x equal to 2, we have 3 favorable events are there out of 8 events. So P of x equal to last one is 3. So for 3 we have only 1 possibility is there. 1 favorable event is there out of 8 events. So therefore the probability distribution, x values are here 0, 1, 2, 3 and the total and P of x equal to x. So that is equal to 1 by 8, 3 by 8, 3 by 8 and 1 by 8 and the total is 1. Okay, so this is our third question. So now coming to the fourth question, if expectation of x equal to 7 and expectation of x square equal to 40, find the value of expectation of 5x square minus 11x plus 8. So we need to write like this. So expectation of 5x square minus 11x plus 6. According to the properties of the expectation or mean, so we can write expectation of 5 into expectation of x square minus 11 into expectation of x plus expectation of 8 is 8. Okay. So 5 into expectation of x square is 40 minus 11 into expectation of x is 7 plus 8. Okay, so this is the required solution. After simplification, we will get the answer. Now coming to the state the definition of discrete and continuous random variables with an example. So actually random variables are two types. First one is discrete random variable and second one is continuous random variable. So discrete random variable is nothing but if the range of random variable is finite, then we can say that that is discrete random variable. Example is tossing two coins. Tossing two coins, we will get x equal to 0, 1, 2. 0 hits, 1 hit, 2 hits. Okay. So this is the example for discrete random variable. So what is the definition of discrete random variable? If the range of random variable is finite, then we can say that that is discrete random variable. So coming to the next question, continuous random variable. So if the range of random variable is interval of two real numbers, then we can say that that is continuous random variable. Example, the students heights of the students in the classroom may be 4 feet to 6 feet. 4 feet to 6 feet. So then the example is here x equal to 4, 6. So what is continuous random variable? So if the range of random variable is interval of two real numbers, interval of 4, 6. So that is continuous random variable. So now coming to the next question, list out the important properties of probability density function. So for probability density function, what is probability density function? That is nothing but integration or continuous probability distribution. So here we have two properties. First property is f of x greater than or equal to 0 and the second property is integration over minus infinity to infinity f of x dx equal to 1. Okay. So now next question, find the probability distribution of getting number of tails if we toss 3 coins. Okay, so already we have find the, so same like third question, the probability distribution for getting tail and getting head both are same. So here we will get the probability distribution. Our probability distribution table is, so x equal to 0, 1, 2, 3 and total. So p of x, or p of x equal to x, that is nothing but 1 by 8, 3 by 8, this is 3 by 8 and this is 1 by 8. 1 by 8. Total is always equal to 1. So this is nothing but f of x. Okay. So and also we need to calculate mean. So what is mean? So mean is nothing but mu, that is equal to expectation of x. Actually this is the formula. So that is summation x into f of x. So that means 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. So this is our mean. Now next question is, state the definition of mathematical expectation of the probability distribution function. So here we have a formula, mathematical expectation for probability mass function is there and probability density function is there. So expectation of x equal to summation x into f of x. So here if expectation of x equal to, in density function expectation of x equal to integration over minus infinity to infinity x into f of x dx. Okay, so like that expectation of x square equal to x summation x square into f of x. So this is expectation of here x square equal to integration over minus infinity to infinity x square f of x dx. Okay, similarly expectation of x power n equal to summation x power n into f of x. So here also same expectation of x power n equal to integration over minus infinity to infinity x power n into f of x dx. Okay, so now coming to the next question, state the mean and variance of the probability mass function. So mean of the probability mass function. In probability mass function, mean is nothing but mu, that is nothing but expectation of x. So that is equal to summation x into f of x. So like that variance. So variance is nothing but sigma square, that is equal to variance of x, that is summation x square f of x minus mu square. So these two are the formulas for probability mass function. So like that next question is, state the definition of mean and variance of the probability density function. State the definition of mean and variance of the probability density function. In probability density function, mean, that is mu, that is nothing but expectation of x, that is equal to minus infinity to infinity x into f of x dx. and variance, that is sigma square equal to, so integration over minus infinity to infinity x square f of x dx minus mu square. So this is the formula for mean and variance of the probability density function. So now coming to the next question, find the probability distribution of sum of scores on dice if we throw 2 dice. So sum of scores on dice if we throw 2 dice. So if we throw 2 dice means the probability is, so x equal to 1, 2, 0, 1, 2. So if we throw 2 dice. So 11th question is, now coming to the 11th question, find the probability distribution of sum of scores on dice if we throw 2 dice. So if we throw 2 dice means we will get the sample space consists of 1, 1 up to 1, 6, 2, 1 to 2, 6, like that 6, 1 to 6, 6. So total 6 square, that is 36 possibilities are there. So total number of events are here 36, and if we throw 2 dice, the sum of scores on dice, that means we have to add 1, 1. So 1, 1 is 2, and then the random variable is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So up to 12 only. So 6 plus 6 is 12, right? So up to the random variable is up to 6, 12. Okay, so then we have to find the probabilities for P of x equal to 2. So here for x equal to 2, we have 1, 1. 1 plus 1 is 2. So total 2 probabilities are there out of 36. So P of x equal to 3. So for sum 3, we have to write 1, 2, 2, 1. So 1 plus 2 is 3 and 2 plus 1 is 3. So that is 3 by 36. So like that we can find up to P of x equal to 6. So that is 1, that is only 6, 6. So total 1 by 36. Okay. So that is the answer. This is 1 by 36. So 1, 1, only one possibility is there. That's why that is 1 by 36. For P of x equal to 3, we have 1, 2, 2, 1, that is 2 by 36. Two possibilities are there. 2 by 36. So for x equal to 6, 6, 6, only one possibility is there. So that is 1 by 36. Okay, so like that we can find. Then the next question is, out of 24 mangoes, 6 mangoes are rotten. If we draw 2 mangoes, obtain the probability distribution of number of rotten mangoes that can be drawn. If also find the expectation. So here we need to find here total number of mangoes are 24. In that 6 mangoes are rotten, and that means 18 were good, right? So now what is our random variable? Random variable is here. We have to choose the number of rotten mangoes. So here 0 rotten, total possibility is there for 2 mangoes. So for 2 mangoes means here 0 mangoes are there, 1 rotten mango is there, 2 rotten mangoes are there. So first of all we need to find for P of x equal to 0. So first rotten mango, 0 rotten mangoes. So we have to choose 0 rotten mangoes from 6 rotten mangoes. That means 6 is 0. So remaining 2 we have to take from good mangoes. So total 24 C2. Okay. So n equal to 24 C2. So P of x equal to 1. So that is nothing but 6C1 into 18C1 divided by 24 C2. Okay. So we have to choose 1 rotten mango from 6 rotten mangoes. Remaining 1 from we have to choose from good. Okay. So now we have to find for P of x equal to 2. So that is 6C2 divided by 24 C2. Okay. So we have to put everything in table 0, 1, 2. So that is P of x equal to x. So we have to put P of x equal to 0 value here, P of x equal to 1 value here, P of x equal to 2 value here. So after that we have to find the expectation. So what is the expectation formula? So expectation of x equal to summation x into f of x. We know that this value is nothing but f of x. So this is small x. Okay. So 0 into this value plus 1 into this value plus 2 into this value. Okay. So that is summation x into f of x. So now coming to the next question, if x is a random variable, then show that e of x plus k equal to e of x plus k. So we have E of x plus k equal to, that is capital X plus k equal to, the formula is, so we know that the expectation of x equal to summation x into f of x, right? So that means here we have summation x into, instead of x we have x plus k, so x plus k into f of x. Okay, so this is separate the terms, summation x into f of x and plus summation k into f of x. So this is summation x into f of x plus I am keeping k outside of the summation, that is summation f of x. So we know that the total probability is always equal to 1, so that's why this is 1. And we know that this is summation x into f of x is already we have written now, so that is expectation of x. Okay, so that is nothing but expectation of capital X plus k. Otherwise we can write small x also. Okay, so that is the derivation. So coming to the next derivation, show that sigma square equal to E of x square minus mu square. So here we have to use the variance formula. So that is expectation of x minus mu whole square. So which will be in the form of a minus b whole square. That is a square plus b square minus 2ab. So now expectation of x square plus expectation of mu square is nothing but mu square, because expectation of a constant is constant, minus 2 mu into expectation of x will get. Okay, so expectation of x square plus mu square minus 2 mu, and we know that expectation of x, so expectation of x is nothing but mu, because mean is nothing but, always we can write a mean mu, that is nothing but expectation of x, that means expectation of x is nothing but mu. Okay, so from that we can write expectation of x square minus plus mu square, and here we have minus 2 mu square is there. So that is nothing but minus mu square. Okay, so this is the derivation. Now coming to the 15th question, state the definition of the probability mass function and probability density function of random variables. So here for the probability mass function, and this is probability density function. So if x is a discrete random variable, then the function f of x is said to be probability mass function if it has the following properties. The first property is f of x greater than or equal to 0, and second property is summation f of x equal to 1. And the probability density function, here x is a continuous random variable, then the function f of x is said to be probability density function. Here first case is f of x greater than or equal to 0, and second case is integration over minus infinity to infinity f of x dx equal to 1. Now 16th question. If x is a discrete random variable, then show that variance of ax plus b equal to a square into variance of x. So here let us consider y equal to this term. Okay, so that is ax plus b. Okay, now so we have to apply the expectation on both sides. So expectation of y equal to expectation of ax plus b. So that is nothing but a into expectation of x plus b. So let us consider this is equation 1 and this is equation 2. So then do 1 minus 2. So this is y minus e of y equal to, so this is ax plus b minus a expectation of x minus b. So b get cancelled, we will get ax. So if I take a as common, then this will be a minus expectation of x. So now I am taking squaring on both sides and along with apply the expectation on both sides. So then we will get expectation of y minus e of y whole square, that is equal to a square into expectation of x minus e of x whole square. So we know that this is nothing but variance of y, that is equal to a square into variance of x. Okay, so but we know that what is y, already we have assumed no. So let y equal to a plus ax plus b no. So that's why this is variance of ax plus b equal to a square into variance of x. So that is the derivation. So now coming to the next question, state the classical definition of probability. Probability definition is P of E equal to m by n. If a fair coin is tossed 6 times, calculate the probability of getting 4 heads. So same like this one no. So this is also same problem like third one, like third question. So like third question we can calculate. And this is also same. State the definition of different types of random variables with example. So there are 2 types of random variables. So what is random variable? In any random experiment, So what is random variable? In any random experiment, the sample space associated with the real number is called random variable. So actually random variables are two types. First one is discrete random variable and second one is continuous random variable. So what is discrete random variable? If the range of random variable is finite, then we can say that that is discrete random variable. For example, if tossing two coins, we'll get if we toss two coins, means that the random variable consists of x equal to capital X equal to 0, 1, 2. For if we toss three coins, means then the random variable consists of x equal to 0, 1, 2, 3. So that is the example for discrete random variable. Coming to the continuous random variable, what is continuous random variable? So if the range of random variable is interval of two real numbers, then we can say that that is continuous random variable. So already we have discussed the same example now. So that is if the heights of the students in the classroom may be 4 feet to 6 feet. So that means we can write the x equal to 4, 6. So this is the example for continuous random variable. So coming to the next question. So outline the classical definition of probability. A coin is tossed 9 times and calculate the probability of getting 5 heads. So this is also like 17th question. And the last question is in part A is state the definition of random variable with an example. Already I have discussed about random variable. So random variable is nothing but in any random experiment, the sample space associated with the real number. So tossing two coins. So tossing 3 coins means we'll get x equal to 0, 1, 2, 2, 3. So now coming to the part B, long answer questions. Our first question is, let x denotes the maximum of two numbers that appear when a pair of fair dice is thrown once. Calculate. First one is probability, discrete probability distribution, and second one is expectation, and third one is variance. So if we toss, if we throw two dice, a pair of dice is thrown, no, so we'll get 1, 1, 2, 6, 6. That means we'll get 6 square. That means 36. Total 36 elements. Okay. So in that we have to take only maximum values. In 1, 1 maximum value is 1. In 1, 2 maximum value is 2. In 1, 3 maximum value is 3. So like that we can find up to 6, 6 is there. So here in 6, 6 the maximum value is 6. So therefore x equal to 1, 2, 3, 4, 5, 6. So this is for maximum of two numbers. In maximum of two numbers, the random variable consists of 1, 2, 3, 4, 5, 6. So what about the probabilities? We need to find the probabilities for those random variables. So in 1, 1, that is maximum. So that is 1 by 36. So in 1, so for 2 means in 1, 2, 2 is maximum. In 2, 1, 2 is maximum. In 2, 2 also 2 is maximum. So like that we will get 3 by 36. Okay. So like that we can find the probability distribution table. So 0, 1, 2, 3, 4, sorry, not 0. X is from 1, 2, 3, 4, 5, 6, right? So what about the probabilities? Probabilities are, this is 1 by, for probability of 1, that is 1 by 36. Probability of 2, that is 3 by 36. So that is 5 by 36. Next 7 by 36. 9 by 36, we'll get 11 by 36, like that. Okay. Then total probability is equal to 1. So this is our discrete probability distribution or the distribution table. So expectation of x, we know that expectation of x are, that is nothing but mean, mu equal to, the formula is summation x into f of x. And variance, so coming to the variance, variance equal to, that is nothing but sigma square equal to summation x square f of x minus mu square. This is the formula. So now next question. X denotes the number of heads in a single toss of 4 coins. Examine p of x less than 2, and the second one is probability of 1 less than x less than or equal to 3. So if we toss 3 coins means we'll get n equal to 4. Okay. So and getting number of heads. First of all, we need to calculate the probability distribution table like this. So after that, we have to calculate p of x less than 2 means, so that is p of x equal to 0 plus p of x equal to 1. Okay. So just we need to calculate p of x equal to 0 and p of x equal to 1. So 1 less than x less than or equal to 3 means, so p of x equal to 2 plus equal to 3 is there, no? We need to calculate P of x equal to 3. So now, next question. A random variable x has the following probability function. Here they have given that x values, P of x, that is nothing but f of x values. Calculate the expectation of x. We know that expectation of x equal to summation x into f of x. And variance. So variance of x equal to, that is nothing but summation x square f of x minus mu square. So what about the standard deviation? Standard deviation is nothing but at the root of variance. Okay. And the last question. So and fourth question is, and the next question is, find the mean and variance of the uniform probability distribution given by f of x equal to or p of x equal to 1 by n. So here x is from 1, 2, 3 and so on n, and f of x, this is f of x is nothing but p of x here. So here we have to take uniform distribution, no? This is 1 by n, this is 1 by n, this is 1 by n, so on, this is also 1 by n. Okay, so here we need to calculate mean and variance. So what is mean formula? So mean is nothing but summation x into f of x. Okay, so x into f of x, 1 into 1 by n plus 2 into 2 by n plus 3 into, 1 into 1 by n plus 2 into 1 by n plus 3 into 1 by n plus and so on n into 1 by n. That is mean. So next variance. So variance is nothing but summation x square f of x minus mu square. So what is mu value? This is our mu. Mean is nothing but mu here, and we need to calculate 1 square into 1 by n plus 2 square into 1 by n plus 3 square into 1 by n plus and so on n square into 1 by n. Okay, so we know that n into n plus 1 by 2. So we'll get from this, so 1 into 2 into 1 plus 2 plus 3 and so on n is nothing but so n into n plus 1 by 2, we have to use this formula here, and also 1 square plus 2 square plus 3 square plus and so on n square is nothing but n into n plus 1 into 2n plus 1 divided by 6. You can substitute these values here, we'll get the answer. Okay, uniform distribution means everywhere we'll get 1 by n only. Next question. A random variable x has the following probability function. So here x values are there, same f of x values are there. So this is also like third question. Okay, so expectation of x equal to summation x into f of x, and variance of x equal to summation x square f of x minus mu square, and standard deviation is nothing but under root of variance. Now coming to the next question, the length of time in minutes that a certain lady speaks on the, so this is our function. So here they have given the function, that is a function a equal to function f of x equal to a into e power minus x by 5, where x greater than or equal to 0 and 0 otherwise. So here we have two cases. So first one is x greater than or equal to 0 means 0 to infinity. So this is otherwise case, no, that is nothing but 0 to minus infinity to 0. So here we have to calculate capital A, that makes f of x is a probability density function. In probability density function means, so in the first case we need to use minus infinity to infinity f of x dx equal to 1. Okay, so split the limits according to our function. So minus infinity to 0 plus 0 to infinity. At 0 to infinity the function will be exist. So by using this formula we can find the a value. Okay, so now coming to the next question, calculate the probability that she will take over the phone is more than 20 minutes. That means here we have to take x greater than or equal to 20 minutes. Okay, more than 20 minutes or greater than 20 minutes in continuous equal to, greater than or equal to and greater than, both are same. So here, so greater than or equal to 20 means 20 to infinity. Okay, so 20 to infinity f of x dx. So that means here we have to take our function a into e power minus x by 5. So coming to the next question, here x denotes the sum of two numbers that appear when a pair of fair dice is tossed. Estimate first one distribution function, that is nothing but discrete probability distribution or probability distribution table, and second one is mean and third one is variance. So sum of two numbers that appear. So here if we toss two dice means we'll get 1, 1 to 6, 6. Okay. So sum, if we do this, sum means 1 plus 1 is 2, right? So that's why the random variable consists of 1, 2, 3, 4, 5, 6. Because sorry, sum, no. Already we have discussed this problem. 1 plus 1 is 2. 1 plus 2 is 3. So like that we will get x equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 6 comma 6 plus 6 is 12. We have to find the probabilities. So p of x equal to 2, p of x equal to 3 we can find. So like that p of x equal to 12. So for p of x equal to 12, so only one probability is there, that is 6 comma 6. So that is 1 by 36. Okay. So from that we can write the table, distribution table. So see 1, so that's 2, 3, 4, 5, 6 up to 12. So p of x equal to 2 means 1 plus 1 is 2, that is 1 by 6. So for the 3, so 1 plus 2 is 3 and 2 plus 1 is 3. So that is 2 by 36, 3 by 36 we'll get like that. Okay. So this is our distribution table, and find mean. So mean means here, mean is nothing but summation x into f of x. And the next one is variance. Variance is same formula, summation x square f of x minus mu square. So here mean is nothing but mu. So coming to the 8th question. So here they have given the function. So it is continuous probability distribution f of x equal to e power minus x, x greater than or equal to 0. Greater than or equal to 0 means 0 to infinity. 0 where x less than 0, that is minus infinity to 0. Okay, so if so, estimate the probability that variate having this density will fall in the interval 1 comma 2 and calculate the cumulative frequency of f of 2. So 1 comma 2 means here we need to calculate 1 to 2 f of x dx. Okay, so 1 comma 2 means, so for the first question we have to calculate integration over 1 to 2 f of x dx, and also we have to calculate f of 2. So here f of 2. So we have one formula, that is f of x equal to, that is nothing but p of x less than or equal to x. That is equal to integration over minus infinity to x f of x dx. Okay. So just we have to substitute the values here. So we need a capital F of 2, no. So that means here we have to substitute minus infinity to 2 f of x dx. But the function will be split like this, no. So we need to write minus infinity to 0 f of x dx. So this will be 0 and 0 to 2 f of x dx. We need to calculate this one. Okay. Now coming to the next question. Here the probability density function is f of x equal to kx cube, 0 less than or equal to x less than or equal to 3 and 0 otherwise or elsewhere. So we need to calculate k. So how to find k value? By using integration over minus infinity to infinity f of x dx equal to 1. So by using this value we can calculate the k value. Here the limits are 0 to 3. So directly we can write f of x dx equal to from 1. From that we can calculate k value. Okay. So then also we can find the probability between, that means probability of 1 by 2 less than or equal to or less than x less than 3 by 2 or less than or equal to 3 by 2. That means we need to calculate 1 by 2 to 3 by 2 f of x dx. Okay. Now coming to the 10th question, a random variable x has the following probability function. So here they have given that x values and f of x values. So we need to find the k value. How to find k value in probability mass function or discrete probability distribution? So we can find k value by using summation f of x equal to 1. So summation of all these values is equal to 1. So after that, so here we have 7, that is 7 k square plus k, I think. Okay. So and the second one is, and the second one answer is p of x less than 6 means, so we have p of x equal to 0 or p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5 is there. And coming to the p of x greater than or equal to 6, just you can write 1 minus p of x less than 6. Just 1 minus, you can write this value here. Okay. Now coming to the next question, let x denotes the minimum of two numbers that appear when a pair of a dice is thrown once. calculate discrete probability distribution. That means the probability distribution function here we need to calculate, and our probability function and expectation and variance. So here if we throw two dice, we'll get 1 comma 1 to 6 comma 6, right? Means here what is our question here? X is minimum of two numbers. Minimum of two numbers means, so in 1 comma 1 minimum value is 1. So in 2 comma 2 or in 2 comma 3 the minimum value is 2. So 3 4 in 6 comma 6 the minimum value is 6. Okay, so we need to find the probabilities for those random variables in 1 comma 1 in 2 comma, sorry, so we'll get like this. I will tell you. 4, p of x equal to 5 and p of x equal to 6. Okay, so p of x equal to 1 means 1 in 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6 are 2 comma 1 in 3 comma 1, 4 comma 1, 5 comma 1 in 6 comma 1. 1 is minimum. So that's why total possibilities are, I think, 11 by 36. So this is 9 by 36. This is 7 by 36. This is 5 by 36, I think. This is 3 by 36 and this is 1 by 36. Once check whether it is, so in p of x equal to 6, we have only one possibility, that is 6 comma 6. In 6 comma 6, 6 is minimum. So in 1 comma 5, 5 comma 1 and 5 comma 5. So 5 is minimum. So like that we can calculate the p of x values. So therefore x equal to 1, 2, 3, 4, 5, 6 and the total, and p of x equal to x, that is equal to 11 by 36, 9 by 36, 7 by 36, 5 by 36, this is 3 by 36, 1 by 36, total is 1. So first, this is our first question, discrete probability distribution table or distribution, and the second question is expectation of x, that is nothing but summation x into f of x. We know that p of x equal to x is f of x. And third case is variance. So variance is nothing but summation x square f of x minus mu square. And coming to the next question, here they have given that x values and f of x are p values. So already we have discussed. So how to find k value? By using summation f of x equal to 1. And mean is nothing but expectation of x, this formula only, and variance is this formula. And coming to the next question, a continuous random variable has the probability density function. Here they have given that f of x equal to some value and the mean, variance, and also find k. So how to find k value? So first we need to find the k value. So the k value is based on to find the value by using this formula. So that is integration over minus infinity to infinity f of x dx equal to 1. From that we can find k value. So what is mean here? So mean is, in the second case we need to find mean. So mean is nothing but here minus infinity to infinity x into f of x dx. And the variance is integration over minus infinity to infinity x square f of x dx minus mu square. So here x greater than or equal to 0 means 0 to infinity. So otherwise case is nothing but minus infinity to 0. Just follow this procedure. So everything is same. Coming to the next question, if the probability density function of a random variable is, here they have given that f of x equal to some value and same procedure. So here also we need to find the k value by using this formula, and p of probability of 0.1 less than x less than 0.2 is nothing but integration over 0.1 to 0.2 f of x dx. So what about this one? So this is nothing but a probability of x greater than 0.5 is nothing but here this is minus infinity, sorry, 0.5 to, actually we need to write infinity, but here we have 0 to 1. So that's why we have to write integration over 0.5 to 1, because here we don't have, actually x greater than 0.5 means 0.5 to we need to write infinity. But in this question we have 0 to 1 limits. So that's why we need to write 0.5 to 1 f of x dx. And the next question is here same procedure, x is there, f of x is there. So we need to find the expectation of x. So that is expectation of x equal to summation x into f of x, and variance, that is variance of x equal to summation x square f of x minus mu square, and standard deviation is nothing but under root of variance. Now coming to the next question, if x is a continuous random variable whose density function is. So here they have given that f of x value, and here we need to find f of x equal to expectation of 25x square plus 30x minus 5. So for this we have to write expectation of x square minus plus 30x minus 5. So that is nothing but 25 expectation of x square plus 30 expectation of x minus expectation of 5 is 5. Okay, so first of all, we need to calculate here expectation of x square. So in continuous, here x is a continuous random variable. So what is expectation of x square? So expectation of x square is nothing but here integration over minus infinity to infinity f of x, x into x square into f of x dx. So expectation of x square is nothing but integration over minus infinity to infinity x square f of x dx. And expectation of x is nothing but integration over minus infinity to infinity x into f of x dx. But here the limits are 0 to 1. So split the limits like integration over minus infinity to 0, 0 to 1, 1 to 2, and 2 to infinity. So this case the function is 0, and here we will get the cases that is the functions x and 2 minus x. Okay. So after that substitute these two values over here, we will get the solution. Now coming to the next question, find the cumulative distribution for the function for a continuous random variable x is capital F of x is here they have given that 1 minus e power minus 2x where x greater than or equal to 0, 0 where x less than 0. So evaluate density function of f of x. So how to find the f of x? We know that small f of x equal to d by dx of capital F of x, d by dx of capital F of x. So from that we can calculate this density function, this function, and mean. So what is mean? So mean is nothing but in continuous, the mean is integration over minus infinity to infinity x into f of x dx. And variance is integration over minus infinity to infinity x square f of x dx minus mu square. So by using these three formulas, we can find these three questions. Okay. So x greater than 0 means actually 0 to infinity, x less than 0 means minus infinity to 0. Next, the 18th question. Two coins are tossed simultaneously. Let x denotes the number of heads. So that means here we will get x equal to x values are 0, 1, 2, and p of x equal to, that is nothing but f of x equal to, we need to find the first distribution table. So now I am finding the distribution table. So for x equal to 0, this is 1 by 4, and this is 2 by 4, and this is 1 by 4, and the total is 1 actually. So then, so what is e of x? First one is e of x formula is summation x into f of x. And second question is expectation of x square, summation x square f of x. Third one is expectation of x cube, that is summation x cube f of x. And fourth one is variance. Variance of x is nothing but summation x square f of x minus mu square. We know that expectation of x is nothing but mu. Okay. And coming to the 19th question. So is the function defined by f of x equal to, they have given like 0 where x less than 2, 1 by 18 into 2x plus 3 where 2 less than or equal to x less than or equal to 4, 0 where x greater than 4. So a probability density function. So here we need to find the probability density function and estimate, is a probability density function, and that means it satisfies the two properties of probability density function. First one is f of x greater than or equal to 0, and second one is minus infinity to infinity f of x dx equal to 1, and estimate the probability that a variate having the f of x as a density function will fall in the interval. So just we need to calculate 2 less than or equal to, probability of 2 less than or equal to x less than or equal to 1, and that is equal to, this is nothing but integration over 2 to 3 f of x dx. So 2 to 3 f of x dx, that function will be exist here. So a 2 to 3 means a 2 to 4 it will be exist, and here we need to calculate, we need to find integration over minus infinity to infinity f of x dx equal to 1. Just we have to prove whether it is probability density function or not by using this formula. So for the second question, we have to calculate by using this formula. And coming to the last question in part B, so the probability density function of a random variable x is f of x equal to k divided by x square plus 1, where minus infinity less than x less than infinity. So find k value and the distribution function f of x. So here observe carefully how to find k value. So by using the second property of probability density function, that is integration over minus infinity to infinity f of x dx equal to 1. So this is our first question formula. And coming to the f of x, we know that capital F of x equal to probability of x less than or equal to x. We know that that is nothing but integration over minus infinity to x f of x dx. Okay. So by using this formula, we can find capital F of x. So now coming to the part C, problem solving and critical thinking questions. So first question is, they have given that f of x equal to 3x square where 0 less than x less than 1 and 0 otherwise. So calculate A. So how to calculate A? If probability of A less than or equal to x less than or equal to 1, that is equal to 19 by 18. Actually, if you want to find A value, we have to use the probability density function second property, that is minus infinity to infinity f of x dx equal to 1. But here they have mentioned that A less than or equal to x less than or equal to 1, that is equal to 19 by 81. So that means here we have to calculate A to 1 f of x dx equal to 19 by 81. Okay, so here the function is 3x square. So from this we can calculate A value. So second question, here also same. They have given that f of x equal to 1 by 9 x into e power minus x by 3 where x greater than 0. So that means 0 to infinity. So 0 otherwise, that is minus infinity to 0. So if the total production is 12 million kilowatts, kW hours, determine the probability that there is a power cut on the given day. So when it will be power cut if x greater than or equal to 12. Okay, so here we need to calculate first probability of 0 less than x less than 12. So after that probability of so greater than or equal to 12. Okay, so greater than or equal to 12 means 1 minus probability of 0 less than x less than 12. So like that we can calculate. So probability of 0 less than x less than 12 means 0 to 12 f of x dx. Just you need to substitute this function here. After that we can calculate the probability of 0 less than x less than 12. So we'll get this one. After that we have to find probability of x greater than 12 means 1 minus p of x probability of x less than 12 or probability of 0 to 12. So like that we can calculate. Now coming to the third question, a fair coin is tossed until a head of 5 tails occurs. Find the expected frequency of E of tossing of the coin. So here we have to use the same procedure first of all we need to find the probability distribution table. After that we have to find the expected frequencies. So how to find the expected frequency? We have formula, that is summation x into f of x. Okay, so here we will get x values and p of x values. Okay, so now coming to the next question, a pair of fair dice is tossed. Here also x denotes the twice the appearing on the die. So when it will appear in twice. So if it is 1, 1, then it will appear twice. So that means 1, 2, 3, 4, 5, 6. 6 possibilities are there. So those are x values. We need to find the probabilities. So after that, construct the probability distribution. This is our distribution table. Okay. So hence find mean and variance. So mean formula is summation x into f of x, and the variance formula is summation x square f of x minus mu square. So now coming to the next question, f of x equal to k e power minus modulus of x. Okay. So first of all we need to calculate k value first, evaluate k. So then mean, variance, and also find this one. Okay. So for here main important thing is, remember, so modulus of x where x modulus of x equal to x where x greater than 0. Modulus of x equal to minus x where x less than 0. X greater than 0 means 0 to infinity. X less than 0 means minus infinity to 0. So we need to remember these values, these limits first. So how to find k value? So by using integration over minus infinity to infinity f of x dx equal to 1. And the mean is, in continuous mean is integration over minus infinity to infinity x into f of x dx. And variance is integration over minus infinity to infinity x into f of x dx minus mu square. So what is mu? Mean is nothing but mu. So what is this value? So for that we need to just probability of 0 less than x less than 4 is nothing but integration over 0 to 4 f of x dx. That's it. And the last sixth question is if f of x equal to ax square where 0 less than x less than 1, here also same parallel function, then calculate a value. How to find a value? So by using the second property of probability density function, that is integration over minus infinity to infinity f of x dx equal to 1, by using this one we can calculate a value. So coming to the seventh question, so this is also based on probability density function. Here they have given that f of x value x greater than 0, x greater than 0 means 0 to infinity. So less than 0 means minus infinity to 0. So we have to find expectation of x. So in continuous expectation of x is integration over minus infinity to infinity x into f of x dx. Just we have to split the limits like minus infinity to 0, 0 to infinity. So next expectation of x square. So integration over minus infinity to infinity x square f of x dx. This is the formula for expectation of x square. And last one is variance of x. Variance of x equal to integration over minus infinity to infinity x square f of x dx minus mu square. So what is mu? Mu is nothing but expectation of x. And eighth question is if expectation of x equal to 10, variance of x equal to 1, then calculate this one. So this is nothing but 2x square plus this is 20x. Okay, so that is 2 into expectation of x square plus 20 into expectation of x. Okay, just what is variance formula? We know that variance formula is in expectation of x square minus expectation of x whole square. So by using this formula and these two values, we can find this one. And coming to the next question, a discrete random variable x has the following probability distribution function. So this is x value and this is p of x, that is nothing but f of x. And calculate k value. How to find k value? So by using summation f of x equal to 1. So second question, for the second question, p of x less than 3 means, so p of x equal to 0 plus p of x equal to, sorry, here we don't have 0 now. So just, so p of x less than 3 means p of x equal to 1 plus p of x equal to 2. Just we need to calculate p of x, this one plus this one, 2k plus 4k. So coming to the next question, this is nothing but x greater than 5. So we need to take only these values, p of 7 plus p of 8 plus p of 6, sorry. So p of x greater than 5 means that is p of 6 plus p of 7 plus p of 8 or p of x equal to 8. So 12k plus 14k plus 4k. So that is our answer. So now coming to the last question in part C. So find the continuous random variable x whose probability density function is f of x equal to cx into 2 minus x where 0 less than or equal to x less than or equal to 2 and 0 otherwise. So here we need to calculate c. How to find key c value? By using integration over minus infinity to infinity f of x dx equal to 1. But here the limits are 0 to 2. 0 to 2 f of x dx equal to 1. Okay, so second case is mean. So mean is nothing but integration over minus infinity to infinity x into f of x. And variance. Variance is sigma square equal to integration over minus infinity to infinity x square f of x dx minus mu square. So mu is nothing but mean. Okay, so this is our question bank discussion on module 1 random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.